The Americans are in a tough spot when it comes to healthcare. Their medical bills are skyrocketing and many can't afford to see a doctor. Some clever people are taking matters into their own hands. But there's an issue.
I have no idea I'm looking at, Kevin.
We're not qualified for this.
Let me know if there's anything, if my toe's broken and I should see a doctor or if I'm fine.
I found this leaderboard. It's for interpreting chest x-rays. They have this dataset which looks something like this. Microsoft, Stanford, Google. We can give it a try. Google recently released a bunch of Gemma 4 models. The smallest version will fit on our GPU, and it's American. We'll be using the library TRL combined with Unsloth, which is key when training on limited setups like mine. It supports a lot of really cool training methodologies, and I want to try one of those. We'll be using GRPO, and we'll reward the model if it answers correctly. The results are in, and this is our model that we're going to be fine-tuning. This is super slow. In GRPO, usually the models are trained to generate some text prior to the final answer. This is called reasoning. It slows down the training by a ton. What if we actually go and remove the reasoning? Oh, that's not good. I think I figured it out. Every time the model tried to answer a question in that step, it got the exact same reward. Then there's nothing to learn from. We need to give the model some medium difficulty questions where it might sometimes get it right and sometimes wrong. Now it must work. Each project where you train a model, it's a learning experience. We haven't learned much yet because nothing is working, but I'm sure we'll get there, right? Change of plans. This paper dropped recently with a new training methodology, self-distillation fine-tuning, and TRL just added support for it. Something happened. You see how it's two parts? The training crashed overnight and I had to restart it. I had this load in 4-bit enabled at some point. It started with the parameter enabled, and when I resumed it, it continued with the parameter disabled. I guess I'll still evaluate it. Wait. 0.87 from a broken run? Run this again and properly. And with that, ladies and gentlemen, the final score is 0.89. Let's go! You can try the model yourself with this UI I built. But now, let me tell you why you shouldn't use it. If the training data doesn't represent you, the model might just not work for you. Also, this model performs great, but the leaderboard is for multiple choice question answering. In the real world, you don't get 4 options when making a diagnosis. Never trust a number blindly. So, why did we do all this? Because understanding where these models fail is just as important as building them. We hit walls, figured things out, and ended up in 2nd place on a leaderboard against Microsoft, Stanford, and Google, all with a gaming GPU under my desk. Isn't that amazing? See you on the next one.